Our next presenter is Charmee Patel from Syntasa. Charmee Patel leads Product Innovation Group at Syntasa and is focused on building next generation behavioral analytic applications. Her team focuses on a class of business problems that aim to understand behavior of individuals based on all their online and offline interactions across multiple channels. Prior to joining Syntasa, she has spent her entire career working with several companies, helping them understand how to handle data and how to make their own data more powerful. She will be presenting a talk titled AI-Powered Customer Analytics in the Age of GDPR. Please join me in giving a big day-to-day welcome to Charmee Patel.
Just happened? Okay. Hi, welcome everybody. I'm hoping to make this talk short because, well, the next thing after this is drinks, and nobody wants to be late for the drinks, right? So before I get started, this is United States, and nobody really cares that much about GDPR, or so it seemed until the California Privacy Act passed, and now suddenly there are two laws that are very, very identical to each other, and suddenly even the companies in US need to understand what it is that they want to do with all the data that they're collecting. And as my MC mentioned, my company, Syntasa, builds a product that helps companies understand how their customers or how their users are behaving through their online and offline journeys. So there's a lot of data that people are collecting, and what do you really do? How do you really handle it so that you can manage privacy of people but still be able to do what you need to do? So just a little bit about what my company does. We are a product that is building an AI-assisted customer analytics platform. Our product actually installs in many different big data ecosystems. It installs in cloud. It runs on in-house Hadoop environments. It's a software that gets installed in people's environments, and it works with a variety of data and handles billions and billions of records in a near real-time manner. Some companies will say trillions. I don't want to say that until we've actually, everybody says that, but it doesn't really happen. We have several customers doing many different types of businesses, starting with ecosystem, content marketing, and then we also work with government agencies. Government also needs to do what we call behavioral analytics, because they also want to find the next kind of people whose behavior is like outliers in terms of consuming data, pushing that data out, or they just don't want people to just start leaking all the secrets outside. We're headquartered right outside of Washington, D.C. We have a pretty big office in London. So when we start talking about customer analytics and the online journeys and offline journeys, a lot of times when we're really talking about data, there's this question that is out there. What do people think about internet privacy? Because you are doing something online, and do you really believe that that data is your own data and nobody should be in the business of collecting that? And you pick like 10 people, and you're going to find a variety of different opinions. It starts from one extreme where somebody says, I don't care what people are doing with my data. I'm an open book, I've got nothing to hide. And the other extreme is where there's people who are refreshing their cache every 30 minutes or cleaning out their cache every 30 minutes, running everything in incognito modes. Those are like two different extremes, and everybody is just, and that's the group that's more paranoid about whatever they're doing. They don't want companies to keep track of them. And I'm guessing that since this is a data con, most of us are working with data, and so, and the fact that I work in the behavioral analytics ecosystem, I work with clickstream data, I work with email data, I work with offline purchases or offline information about users. So when it comes to me, what do I think? Like, that was what people think. This is really what I think most of the data people think. There's data, it's all out there. I can do whatever I want. I can eat as much candy as I want. Nobody's going to stop me. There's going to be a sugar rush at some point. That probably is what happened with GDPR and California Privacy Act, right? And that's sort of where the government comes in. What does the government say? The government says, no, you can't do everything that you want to do. Like, you have to have some rules in place. And what did they do? Not that I agree with everything that is that came out of those rules, because obviously I'm a data person. But there are somewhat of common sense rules. They don't want information to be just stored outside publicly with no understanding of how to secure that data. They don't want actions that happen at a certain point to just be stored forever and forever. They want the users of a company or customers of a company to have some basic rights, that you can go ask that company, what do you know about me? And if I don't like it, maybe I want to ask them to forget everything about me. Now, I don't know if that is fair or not, but that is the right that the government gave to now people who live in California and then people who live in EU. But what does a business really need? Like, when we are really talking about data, what do people in the behavioral analytics ecosystem or customer analytics ecosystem, what are people trying to do? They're trying to create relevant experiences for their customer, and that involves doing a lot of different things. And like, a very common use case that comes across, like an A/B test. Nobody's really trying to violate anybody's privacy by running an A/B test. All they want to do is they want to figure out what kind of experience is better for them as a company. But to even understand that, when they want to run an A/B test, they really need to put people in two different groups, and they need to monitor the behavior or the outcome of that process. And that's why they need this continuity between a person's behavior today, tomorrow, day after tomorrow. And something similar, we do this with a lot of our customers, where we're trying to help them do a behavioral segmentation. Anybody who is their customer, are all of their customers identical? No. Some of their customers are very decisive buyers. They come, they see what they're looking for, they get it, and they leave. There are some customers who are on the other extreme, who don't really know what it is that they want. They're flip-flopping all over the place, and they finally make a purchase. And as an organization, obviously you do want to know what kind of behavior your customers have, so that you can have more relevant experiences. Companies also want to be able to do some sort of a life cycle analysis, that people went from step 1 to step 2 to step 3. At some point, maybe step 4 was not very relevant and they left. But all of these things, a company, a business is justified in really asking this kind of questions off of all of their data that they have collected. But people talk about, what about my privacy? And they are actually right, because because I work with this data on a day-to-day basis, I can actually show this. And to give a real example, I put my own name in here. I didn't want to put a Jane Doe, because once you put a Jane Doe, it's not me, it's somebody else. And you don't think about somebody else the same way as you think about yourself. So searchflights.com doesn't exist. It's a fictitious website. I'm just showing some of the clickstream data about a specific, my journey of buying tickets to LA. And then I went online, I searched for a flight. Oops. Hello? Okay. yeah, so I went online, I searched for flights, after some time I made a purchase, and then at some point I ended up looking for hotels for LA, and then I went ahead and booked my hotel through this whatever fictitious website. Now let's say this company is also, when I signed up to get my flight ticket, I also gave them my email information, and so they sent me an email. I opened that email, I clicked on that email, they sent me probably some other information, some other offers. This is realistic data that pretty much every organization that Syntasa works with has, and they're trying to extract value out of this kind of data to figure out what are the right and relevant experiences for their customer. So now you can see that at this point, it's justified. Like, I do feel in some ways violated. Why does somebody need to know what device I'm using? Why does somebody need to know how am I opening my emails and how much time I spent on a website? Like, you know, that at that point it feels like that is my own behavior. I don't want anybody watching over me. And so when you see data out like this, that's really when it hits you what these regulations are going after. And so at Syntasa we're trying to work, we built this concept called an analytic safe zone. And I'm sure not everybody's thinking about it that way, but there are some companies that have actually built something like this. And so the main thing about an analytic safe zone is that you have all of this data, you're trying to analyze all this data, but it's not really connected back to an actual person. Okay, hopefully it works. And I'll give you an example. There's Kaggle. Kaggle has so much data out there. None of that data is really personalized, right? All of that data, like you look at the data sets that Kaggle is providing, nobody can reverse engineer it to a person. But all sorts of analysis, all sort of analytics and models and everything is possible off of the data that is provided by Kaggle. That shows that you don't need a person's individual information to really be able to do good analytics out of that data. And so if we go back and apply similar mechanisms to the data that we have in our own data lakes and event lakes, then you can see the same information that I had earlier is no longer, there's really nothing about me here. Yeah, there's some person, there's some hash in here, but that's pretty much it. And now none of this is really giving away any information about myself. Even if an analyst was trying to, like, you know, not really worry about leaking any information out there, they're not by, like, you know, just virtue of analysis going to run into my name out there. And before somebody says that, but why do companies need to collect this information? Why are they really, like, who gave them permission to collect this kind of data? And like, you know, I'll give you a real example. If I'm the product manager of searchflights.com, there's definitely two different things that I can see out of here. Let's say I want to decide that whether I should create two different experiences, one experience more geared towards iOS and Mac experience, and another that is more Android and Microsoft kind of experience. Should I create two different experiences? Should I have one unified experience that is common for everybody, all kinds of customers? And in a case like this, it's quite apparent that there are people out there that are using Macs and Androids, and perhaps those kind of people would get lost if I were to just switch around their experiences all over. This is information that the business does need to know. Maybe they are trying to figure out that sending out that email, did that really help? Did that help in increasing the conversion for getting a hotel book, for instance? Again, all of this information is really relevant for a business to be able to do what they need to do to succeed. But by being able to do some stuff like this, they're not really giving away anybody's personal information out there at this moment. So how do we really make this happen? What does Syntasa's typical data architecture look like? So we work with our customers where we are basically collecting information, or our data sources are typically all of these different types of sometimes logs, sometimes streaming kind of data. So we have Omniture logs or Adobe Analytics logs. We're working with Salesforce individual events. We're working with Google Analytics. We're getting email information. We have surveys. We have impression logs that are coming in. If there are advertisements that are going out there, then those DFA logs come in. So we have these input adapters that are really focused on building a unified view of all the activity about what is happening in their ecosystem. But that taps into the whatever data format that is coming from outside. It converts, it does whatever standardization is necessary so that this particular information is available for people to start building out their advanced analytics and models fairly quickly. And then once they have done what they need to do and they have some actions that they want to take, maybe they've identified a bunch of people that are more likely to, let's say, book a hotel through them, then and they want to send out an email, then those individuals are then sent in that email output adapter that taps directly into their email system and sends out the email. So they can basically accelerate all of their data processing and all of their overall customer experience optimization through this fairly quickly. So a very small change in this architecture actually allows us to do this. We've put something called, we've called it key management system. It's not really a good word for it, but we just didn't have a good word, so we're using that for the time being. But we basically stacked something we call key management system on both sides of this data architecture. So looking a little bit further into the key management, what really happens is that we have a key store, and on top of that key store, we basically built a bunch of REST services and some UDFs. Now these REST services and UDFs are sort of working off of exactly the same implementation. And now what happens is and then the rest of the real-time APIs that we have, or any of our data processing, is interacting only through the outer layers of this service. So once that happens, we can use exactly the same implementation across the board. And this gives us a few different advantages. We basically embed our key management system both as a service as well as a library within our data processing ecosystem. It allows us to abstract out our key store because Syntasa deploys in a customer's own big data environment. Every customer has different requirements. Some customers are totally fine with using an open source JKS key store. Some customers want to use Vault. Some customers want to use something else. It's completely custom. It's abstracted away from the rest of the architecture. And now we can actually put in several different options that are, again, configurable. One customer is using DES 256, another customer doesn't care about it and they just want to reduce it so that overall their cost is lower. Maybe some customers want to do key rotation. This allows us to have a lot of configurability within our overall data pipeline, but still keeping that as a separate component by itself. So I'll show a few different sample data pipelines. I'm showing a small subset of what our process graph is, of how data comes from outside from Omniture logs. In this case, it's an FTP server where Omniture is delivering those logs. And we have this process that is built for it. And what it needs to do at this point, it's just this process that needs to change, where we interact with our REST service, get the key, apply our UDF to actually do the encryption that we need to do. And from that point onwards, all the data is really obfuscated. Nobody really sees the real data as is. Another example would be how we have the output adapter. So imagine that we have a few different models that we ran. So let's say purchase propensity and shopper behavior. We have people who were undecisive buyers, but their probability of actually converting is very high, and we still want to send them an email to have them come back to our website. We have these adapters that are now going to the publish process, basically goes and reformats those results in whichever format is needed by the email system, or this is Adobe Audience Manager, it's a DMP. So based on whatever the external party is, it reformats that data. Now at that point, because that is the last point within the entire ecosystem, it can apply the unencryption UDF, and then it can go ahead and push that data out. But it's not going to stay within the unencrypted or plain text data is not going to sit within their own environment for somebody to discover individual identifiers or PII kind of data in the future. This is another example. Syntasa also generates something that we call the serving layer. So whenever people are building models, there's the offline models, and then there's the online serving, like real-time serving of the results. And we have these well, I don't want to call it a process. We have something we've built, and we call it an intelligence hub. The intelligence hub is where all the information about all of the different models that we're running has been deposited. And the real-time serving API basically is going to go off of that. At that point, if there's an external DMP, let's say BlueKai wants to know, I have this visitor, should I show them this ad? You want to figure out on a real-time basis whether you really want to do that or not. At that point, they're sending you some sort of an identifier, an external identifier, which we haven't really stored internally as is, by the way. That is plain text. We have all of that encrypted on our side. So we will encrypt it, match it against our data, see the information that we have, and then push it out. And so this is just a few examples of how the actual processes would work. Now, there's two other things that GDPR requires, and I believe California Privacy Act also requires. One thing is for users to be able to ask the company, what do you know about me? So again, by going through this architecture, it's very easy for us to be able to do something similar where we have all of our data that's sitting internally. We have a process called extract. That process is going to go do whatever is necessary. It grabs the user for whom it needs to generate the user data extract, encrypts that information, goes back for that encrypted identifiers. It's going to grab information from all the data sets, generate the data extract in whichever format the company wants, and then it's going to push it out. And then the second thing is forget me. And this actually comes up a lot. Like, how do you really, so if you're using Kafka, for instance, or if you're using logs, like, how do you really forget something from a log? And can you even generate hosts? And if you go delete data, what does it mean? Like, what does it mean from your statistical analysis point of view? Suddenly started deleting some information. You can no longer go and run any model on top of that later, right? And so we have a simple example. Now, there's no other manipulation I did on this diagram from what I was showing before, but we have this thing called forget me list. The forget me list, what it's basically doing is it's storing the plain text identifiers for the people who requested that they be forgotten. So as soon as any process says, I want to unencrypt this particular person's information because I want to send it out, we go look it up, we find that person in there, we're like, nope, this person doesn't get any personalized experiences because they want us to forget about them. So they don't exist as a known person in our system. You can still keep that data in there from an analytics point of view, but you're really not acting on that data, and you really don't have a way to reverse engineer it. Okay, I did talk about it. few benefits of doing something like this. Again, by putting it in a service in the background, now we can really put options. So Syntasa again is a product that gets installed on many different customers' environments. So we can't just have one behavior and ask all of our customers to abide by whatever we think is right. So the customer, if some customers actually say, no, we don't want to do anything. Some customers may say, I just want to exclude that person. I want to be able to show some default information. So we can control a lot of those things from within here. Also, putting it behind the service has actually allowed us to very quickly experiment with different types of low latency access. Right now we're using Bigtable, but we're also starting to experiment with Redis, and it has worked out very beautifully because we don't have to make many major changes anywhere in our stack to be able to do anything like this. So, so going back to the original architecture that I was showing, now if you look at this, this architecture, what I showed was all of these processes, and all of these processes were really sitting either on the input side or on the output side. And by applying a simple key management, tagging on key management to both of these sides, actually allows us to create this analytic safe zone where nobody really has to worry about what it is that they're doing. All the analysts, all the data scientists, they just go start using their data, do whatever they need to do. They know that they're not really required at that point to do any fancy joins. Like all of that data is reboot always solves, right? So yeah, this analytic safe zone is basically the safe zone where people are really open to do whatever they need to do with the understanding that the statistical properties of that data is not really violated, but it still complies with the rules and regulations in place, and it also does not require them to know anything further about any other security practices that every single person now has to remember to apply. So I guess I did end up finishing on time. So like I know a lot of people are thinking that encryption or cryptographic hash and all of those are nothing new, and that's really the key. We're not really trying to do anything groundbreaking or earth-shattering. All we want to do is do something that is basic. Okay, hopefully this works till the end. So we're doing something that's fairly basic, but it is fairly simple. But by doing it in a systematic way, it actually allows us to avoid duct tape. And I have worked in enough organizations on the data side that I know that people do end up duct taping a lot of solutions together. And you know, every company that is working today with data is going to know this, that data is just going to keep on growing. If you're going to close your eyes and not worry about the security and privacy aspect of it, tomorrow it's going to come bite you back at some point. And it's really important to secure the data, but more than any of this, we are all okay. More than any of this, we're all like, you know, we're data professionals, and we all should keep in mind that privacy does matter. And if we design our system in such a way that nobody's privacy is going to be violated and it's simple enough, it's going to work very well for the organization and for the data professionals. So, well, that's pretty much it. Yeah. So does anybody have any questions?
Oh, you can just say your question.
Okay, perfect.
Yeah.
Hi.
Oh, sorry.
How well that works.
Okay.
Yeah, I'm kind of curious about, like, I guess I'm thinking about HTMs and
Say that again?
HTMs.
What is that?
Oh, so like Workday, like big human capital management systems that have all this employee data. Um, I'm wondering, you could do something where you maybe hash name if you're not tracking the like promotions over time. But if you need to know, you need to know some kind of PII. So like, they would say, okay, let's say I upload a CSV of my employees. Of course, the human cap manager eventually start this manager there. But let's say I wanted to upload something to like the system of all my employees, and then I uploaded 6 months later, and John was first a junior, and now he's a senior. Tracking that, you need to have known something that to track that over time. How do you effectively do that with respect to also being compliant?
So, firstly, like my company, we really focus more on the behavioral data or behavioral analytics side. So we're really, so when you look at the rules that are in place, nobody's really stopping an organization to track an employee performance kind of analysis information. So whatever the rules and regulations would be, they're not really going to apply to a workday kind of system, because at that point it is really about a specific person. But putting that thing on the side, what we do within Syntasa, when I'm really showing that somebody went online, they looked through, they bought let's say a flight, and then they got an email and they open that email, and then they come back and they do something else. You're really at that point still analyzing the steps that occurred in time, right? And so we actually have, so with all of these adapters that we have in place, we also have something we call identity graph that we build in-house. I guess I can show it here. So we also have this thing called identity graph that we're building. So from all the different data sources that you're getting, there is a way for us to actually map a person or an ID from one system to another system to another system to get this continuity. When you're setting up that input data source the very first time, that's really when you're identifying that specific PII kind of data. From that point onwards, the system actually does make an attempt to making sure that it's secure from the rest of the processes. Does that answer your question?
Yeah, I'd be curious to know maybe more of the how behind the identity graph, because it sounds like that handles a lot of from different sources, knowing that following that user path would be analogous to my idea of following a promotion. So following a user path from one place to another and so forth. I'd be curious to know how that works. Like, how does that work? How does it figure that out?
I can show it to you later if you want. But yeah, it works somewhat in a similar fashion.
How is it different to data masking? Is it something similar? Like talk about data masking, like suppose a simple use case like SSN, and somebody wants to read data, like some kind of thing that they're completely anonymize the data saying.
It's essentially the same thing, except that the forethought has been put in place of how you're going to unmask the data when necessary. And you're also going to have a very systematic way of masking it uniformly across all of your different data sources.
And the second question, you do that in memory or you persist to a disk also, always this key management metrics and persist to a disk and read it back.
So we store for the do not forget, for the forget me list, we store the identifiers that requested to be forgotten in plain text. But there's never anywhere in memory or on the disk a pair that we store that this was the plain text and this was the encrypted text. We don't really have that together at any point.
So when you update your identity encryption method, is that fall into your team responsibility or the analytic team to make sure that all the analytics is still correct?
Can you repeat that?
Okay, so if you update it, just fall on your team responsibilities or the analyst team to make sure that all the previous results you running correct for test.
For testing all of this? So I run the product innovation group. So what we do is we actually figure out all of these new, or we figure out how the next architecture is going to look like, how to handle a new data source, how to handle something else. We do a little bit of prototyping. Once that is done, that's going to look fairly similar to what any other big data team is going to do. But at that point, within Syntasa, so our application is, in a technical language, if I were to explain, it's, you can think of it as a process graph, where processes are thought of as reusable components. So first we do the prototyping, we convert those into reusable components. So then when you actually have to do your data processing, you're pulling these processes together, combining that, and then creates your data pipeline. So, so when we want to deploy, like, you know, this data architecture that is up there, when we deploy this to our customers' environment, and they want to bring in their email data, they want to bring in their clickstream data, they want to understand what's happening, start building models, it's really 2 to 3 week effort to really get them up and running and process about a year's worth of historic data that they might have. So it becomes fairly easy. So my role is in getting all of this kind of started, and then our engineering team is the one that finally puts everything in place from the processes point of view.
My question is about when you update it, how you make sure that it won't break anything?
When we update the encryption, so we have done some, so are you familiar with Google's key management service?
A little bit.
So Google's key management service has done something interesting where you can have a key ID, and then internally you can rotate your keys, and the systems just first authenticate themselves, and then they present a key ID, and the system based on the key IDs will automatically do the encryption, decryption, even if the key is changed. Well, my role is more, I'm more on the data and analytics side, so we're working with some of our security folks who really know more details about how that process works. But it seems like a very elegant solution where you don't really have to worry about keeping your a constant key across like years and years.
If there's any more questions.
All right.
Thank you.
Thank you.
And thank you everyone for attending Big Data Day LA. There's a networking session sponsored by BCG Gamma in the Alumni Park. There'll be beverages as well as food, and the winners for the startup will be announced, as well as raffles. Please also visit our sponsors in front of the billboard. They really make this event